Hi guys. Today we'll be discussing our first assignment video, and my name is Yavinaash Naidu Saravanakumar. My matrix number is 198543.
Hello everyone, my name is Yamunan Selvanathan and my matrix number is 199091.
Hi Yamu.
Hi Yavinaash, how are you?
I'm doing good. So regarding the assignment that Dr. Wan gave us, so we have been assigned two questions, one from differentiation and another one regarding integration.
Yes.
So we'll start off with the differentiation question.
Okay. So the first question is log base e multiplied by 2x minus 1. So we will write the question first.
Okay, so let's see what we do. Log a 2x minus 1.
So basically to start we know that log exponential or log e is basically ln.
Yes.
Right? So just rewrite it in the ln form.
So we are just restructuring the question, making it ln 2x minus 1.
Yes. So the next step is basically we have to find which rule we have to use to solve this differential equation. So the rule that I think we have to use in this case is the product rule.
Product rule, yes. Okay.
Which is dy over dx equals to dy over du multiplied by du over dx. So we'll just write the equation first.
Okay, so now using the product rule, we will have to find the u and we'll have to find the v. So
so there's a small mistake.
Just a small,
it is not actually a product rule, but it is known as chain rule.
Chain rule, yeah.
So it is dy over dx equals to dy over du multiplied by du over dx.
So that we are going to use the chain rule. I think it's one of the very important rules in differentiation. UV. So now what we are going to do is we are going to separate the u. We are going to find the u so that later it can be differentiated and substituted to find the differentiation.
Yes.
So we are going to use 2x minus 1 as the substituent for the u.
So you let u equals to 2x minus 1.
So if u equals to 2x minus 1, so if we differentiate u with respect to x,
you get du dx equals to 2x minus 1. When you differentiate, you get 2.
So the power comes down, we use y equals to ax power n rule, and then when we want to differentiate it, we get ax n power n minus 1, and then we will get 2.
Yes, exactly. So we'll put that aside, and now we'll find dy over du.
Yes.
Y is actually our equation there, which is our ln 2x minus 1 is our y, but the 2x minus 1 we already let u become the 2x minus 1. So now the y equation is ln u.
Ln u.
So when we have to, so now we have to find du over dy over du. Sorry. So now we will do the integration. Sorry, differentiation.
dy over du. So since y equals to ln u, so when we differentiate ln, we most probably will get 1 over u.
Yes. When we differentiate ln u, we'll be getting 1 over u. So now we have to find dy over dx. Now we have our dy over du and du over dx value. So we just have to sub inside the chain rule.
The chain rule. So the chain rule says that dy over dx equals to dy over du multiplied by du over dx.
Yes.
So when we look into the equation, we have the two same constants which can be eliminated, which is du, and then when we compare both of it, we will get the dy dx.
Yes.
So
let's do it. But before that, for the dy over du, we have to sub in the value of u, which is 2x minus 1.
Yes.
So sub in inside the equation. So when we differentiate again ln 2x minus 1, we will be getting 1 over 2x minus 1, and then we will multiply it by du dx, which is 2, and our final answer will be 2 over 2x minus 1. That will be our
Final.
dx.
Yes. So the final answer after the differentiation of the logarithm of the exponential of 2x minus 1 is 2 over 2x minus 1.
Yes.
So that will be the final answer. Alright.
Now let's move on to the next question, which is a integration question. So question is to integrate 1 over quadratic equation, which is x squared plus x minus 2 respective to dx. So for this we will be using we'll be using partial fraction method. So now let's just first look at the quadratic equation, which is x squared plus x minus 2.
So we have to find the roots of the equations of x squared plus x minus 2. We can the roots will be x minus 1 and x plus 2. I'm simplifying it into its simplest form. So we rewrite the equation as 1 over x minus 1 and x plus 2. So and then we will substitute it as partial fractions. So and then we will still the integration symbol will be remain, and a over x plus 1 plus b over x plus 2.
So as we know, for the partial fraction method, we have to sub in we have to find the values of a and b. So we will assign value the alphabet a for the first root, which is x minus 1, and alphabet b for the second root, which is x plus 2.
So now we will yes, we have to make the denominators of the partial fractions same, so that we can continue with the we can further the calculation. So now we will have to multiply on both sides the unknown, the constant which is not there, make the denominator same.
Yes.
So for part A we will multiply with x plus 2,
which is the denominator of b,
and for B it will be vice versa.
So on the left side, when we comparing the values of a and b, it will remain as the question, which is 1 over x squared plus x minus 2. Thus the denominators on both left and right hand side will be the same, so it will be eliminated, and the numerators are the only thing that will be remaining as.
So here I will take the x.
So next is we have to group the values of a and b. So then be done according to the power or the degree of x. So if there's more than 1 x power 2 or x power 3, for example, we have to group them.
Sorry, some technical errors, but it's okay.
We have to group them according to their degrees, from the highest degree to the smallest degree. So in this case, it will be x, there's only x and there's no x power 2. So x will be the highest degree, and we have to group x's first, followed by the constants.
And all this equation should be equals to 1.
Yes.
That's the primary rule for partial fractions. So looking into that,
now we have to compare the both values of a plus b and 2a minus b on the right hand side and the left hand side. So to compare, we have to look at the degree of x, just like what I explained just now. So in this case, there's only x on the right hand side, but there's no x on the left hand side. So the value of x on the right hand side will be the value of the constant of the variable x will be equals to 0, since there is no x variable on the left hand side.
So So basically now we have settled for a plus b, which has a constant for x. Now for the one that does not have a constant, like 2a minus b, so it will be equals to 1. So when after calculating for the one with constant x, we will get a certain sum, and then it can be substituted in the next equation for 2a minus b, and then you can find the values of a and b.
Yes, exactly. So for that, now we have to write two simultaneous equations.
Yes.
Which is the first one will be a plus b equals to 0, and the next one will be 2a minus b, which is equals to 1.
1. So maybe on we should I think make a constant an unknown for both equations the same, and then from there maybe we can find. I suggest we go with making a as a subject.
Yes.
So a equals to negative b. So we already have two equations. So now we will substitute the second equation that we get, which is the third equation that we got, which is a equals to negative b, into equation number 2, which will be 2a minus b equals to 1. So when we substitute that, we'll get negative 3 here. B equals to negative 1 over 3. Is that right? So the value of b is negative 1 over 3. So looking at the equation at number 1, which says a plus b equals to 0. So since b is negative 1 over 3, automatically a becomes 1 over 3.
Yes.
So the value of a equals to 1 over 3, while the value of b equals to negative 1 over 3. So now since we've already got the values of a and b, now we can substitute the values of a and b into the partial fractions
To do the integration.
integrations. So it's okay. So let's continue with our partial fraction. Integration. Yeah. So now we will be calculating the integration for the. Most probably we can say it's either partial fractions or by parts.
Yeah.
Integration by parts. So we can categorize this into two types of calculation, but somehow we'll get the correct answer. So 1 over 3 x minus 1 plus negative 1 over 3 x plus 2.
Now, when we look at our bipart equation just now, before we started to find the values of a and b, we will have an equation which is a over x minus 1 plus b over x plus 2. That for now, we have to substitute the values of a and b into that equation. So we'll be getting the integration of a, which is 1 over 3 over x minus 1 plus our value
Negative
of b,
1
which is
over
negative 1 over 3, which will become negative. So minus
1
over 3 over x plus 2. Then we will have to integrate them. So when we integrate 1 over x minus 1 or 1 over any equation of x, we'll be getting ln x.
Yes.
So our constant, which is the values of a and b, we can bring it outside of the integration, the curly bracket. So 1 over 3 will be on the outside.
It's constant for both, so it can be removed out of that symbol, and then we can calculate it with the remaining bypass.
So it will be 1 over 3 on the outside and
integrate
ln x minus 1 on the inside,
and minus ln x plus 2.
minus ln x plus 2.
Time sheet. Time sheet. FP integrated. So for the viewers' information, we've already integrated the question. So after integrating the question,
Minus divided.
sorry.
Minus divided.
So now we have reached the final answer where it's equals to 1 over 3 in bracket ln x minus 1 minus ln x plus 2. So this is the answer that we have received, and this is our working. So for both questions, this is our working. So yeah, the working will be submitted during our class.
Yes.
So since the haze is very bad, so we advise everyone to wear mask and stay healthy. So take care, and we all see you all soon.
Bye.
Bye.